Hey guys, can you hear me? Is this too loud, too quiet? And is the background noise too loud / too quiet? What do I need to adjust? All good, sounds good. No background noise. How about now? Okay. Now that I've done a little mic test at my end, I'll stop the annoying feedback. Alrighty. Thanks for joining in. As per usual, we have Guy Baroni playing in the background because he's a legend and lets me use his music during stream, so big props to him. Fast chat, no, that wasn't an echo, that was me turning on my laptop, which was playing the feed so that I could hear it, and then it heard my voice come out of the laptop and went back into the microphone. So it's not feedback, it's all good. Okay, so hopefully you guys can see where we're at. Right, so for those people who were here last time, where we left off was we were at the point where we were creating name pipes that we were looking to pivot through. And then I got to a point where for some reason things weren't working as they were to begin with. So I thought rather than painfully bash my head on stream that I would figure things out sort of off stream. I'm guessing part of the reason why it's so quiet is because I keep moving so far back from the microphone. Is that fair to say? Maybe what I need to do is lift the mic up somehow. Maybe get an arm or something at some point, or continue to speak a little bit louder, but I'm hoping that you can at least hear me over the top. Anyway, so we got to the point where I was trying to create name pipe handles and it wasn't working. So I finished off the stream and then went away and did all kinds of horrible things to try and figure out what was going on. And it turned out that everything was working as expected. There was just one issue. That issue is that you need one particular privilege, or I was needing one particular privilege in order to create the name pipe that I was trying to create. So for those that don't know, when you use name pipes, they operate over SMB. So all of the SMB authentication and ACL related stuff applies. In the case of Meterpreter pivoting, what we're trying to do is create a name pipe that anyone can connect to, which comes with a few issues, right? So the first one is, by default, when you create a name pipe under the context of a non-privileged user, the only people that can write to that pipe once they've connected to it are administrators and yourself. So if you're pivoting as the same user all over the place, then that's not so much of a problem, but most of the time that might not be the case. So what we want to be able to do is create pipes so that everyone in the domain can connect to it. And that requires creation of different security attributes and applying those security attributes to the named pipe once we spin them up. So in order to do that, you need the SE security privilege or something, which we'll look at in just a minute. And so in order to do that, you either need to run as an elevated user, which makes a bit of sense given that you're mucking with certain attributes, or you need to run as system, for example. So what I've done is I've modified the code. Let me just open it up and I'll show you the area of code that we're mucking with. While I was playing with this took me down a rabbit hole to do with privilege related stuff, as is the nature of development, right? So let's go back up to where we're actually creating the named pipe. Did I type that wrong? Create. Right, sorry, I'm in the wrong file. I need to pivot. All right, so what you can see here is this is the point where we actually try and create the named pipe. Now, after doing the research that I attempted to do, I thought what I need to be able to do is toggle the security name privilege. So if we go to the definition of this, you'll see it's SE security privilege. That's the one that seemed to let me do what it is that I was looking to do. So what I'm doing here is I've created a toggle privilege function, which basically says for this privilege, open the current process token and toggle the privilege such that it is on or off. So this function takes 3 parameters. The first one is the privilege name. The second one is whether or not I want it enabled. And the third is give me the setting that indicated whether it was enabled beforehand or not. Hey Lockifer. So from there, what I'm doing is I'm keeping track of what the previous setting was. And if the previous setting was disabled, then after I finish doing my thing, I want to go through and disable it again. So assuming that I was able to toggle that privilege on, which will work even if it's on, this is a valid check that says that that actually succeeded. What I want to do is go and create this security attributes like I did before, and then when I invoke the creation of the named pipe, I pass this in at the end. That can actually still fail. As soon as that's done, I then check to see whether it was enabled beforehand, and if it wasn't, then I go and turn it off again. So the window of opportunity for that particular privilege to be on is only there for the sake of creating the name pipe to begin with. After that, if things fail, what I do is I fall back on creating the name pipe with the current security attributes. So at the end of the day, I just pass in null for this security attributes parameter at the end, and we get given what the operating system gives us. What I will end up doing is probably adding something to the response packet that tells Metasploit that we've actually got a lower privilege pipe and that only a certain set of users will be able to connect to it. Now, if you're pivoting around as a domain administrator, this might not be a problem. But I don't currently have the infra set up to allow for that to happen. So with that in place, what I did was I pushed on and started looking at the stager. So bear in mind that we create effectively a server here inside Meterpreter, and that server is going to be sitting there with a staged sort of payload ready to serve up to whoever connects to it. So we kind of want Meterpreter to behave a little bit like the Metasploit stager system. So since we were last here, I modified, hang on, let me just, excuse me, let me just open a file that will actually help. I think it's client core.rb under LibreX post Meterpreter. So up here you'll see what I've done. Under this create named pipe pivot function, which I'm actually going to refactor soon, we create a pivot request packet and we add the name of the pipe that was given to us. From there, what I do is I create a new payload type, because what I want to be able to do is say I want this name pipe to be a pivot, and when someone connects to it, I want you to serve up this stager, or this stage I should say. So we include a stager, we include the transport configuration, and then depending on which architecture is given, we say, give them the 64-bit version of MetServe or the 32-bit version. Now this is hard-coded to Windows at this point, but down the track what we will be doing is making it so that you can say, hey, I want you to stage Python payloads, or I want you to stage Java payloads, or whatever it happens to be. But the point is that for now, given that I'm building this on Windows, I thought I would just support Windows to begin with. I then generate some options for stage generation. I've got this new one here called force right handle, which I'm probably going to rename, but the aim here is to force the underlying stager to write code to the stager that copies whatever the current transport handle is over to the configuration block. So as part of the staging process, I know that's a little bit confusing. Let me just explain that a little bit better. Reverse name pipe. So we've got a payload called reverse name pipe. And when we generate this payload, one of the things that we do is down the bottom here, just before the stager gets invoked, the second stage gets invoked, it needs to copy whatever the current handle is, which could be a TCP socket, it could be a name pipe handle, it needs to take that and copy it to the configuration block so that when metserv kicks off, it can reuse that handle. This is not the file that I wanted. It's the Meterpreter loader.rb. Windows. Here it is here. So when things are stageless, we don't actually generate this piece of code because stageless fires outside of the context of a stage, and hence adopting an existing handle doesn't make sense because there is no handle. So what I did originally was set the stageless flag for other reasons, and I was losing out on this piece of code, which was really important. So now what I've done is I've added this force write handle code, which writes whatever the current handle is into the configuration block so that it bubbles through. This isn't so important right now, but it's interesting detail. I'll have to replicate this through all of the other Meterpreters down the track if and when it's actually required. But I think the only thing it'll really apply to is 64-bit and possibly metal, but I'm not sure. Okay, so that means that our stager was able to kick off. The problem I had then was the stager that I wrote for the previous pull request that enabled name pipe pivots, for some reason, doesn't work as expected. And hopefully, given that Brent Cook's watching, I'm gonna dive through this a little bit. It's actually a little bit of a painful process, but bear with me. Okay, so what I need to do is kick off MSF console. I've still got all my debug binaries, but what I need to do is create a new stager that has a breakpoint in it. To do that, I think I was cheating big time. Here you go, you can see my little cheat in code here. So I'm adding a breakpoint right before the stager actually gets invoked. And what I'm going to need to do, let's create a stacked window here. Code, Metasploit framework, Venom. So I'm going to create a 32 pipe desk. I'm going to put CC at the end of this so that I know it's the one that has the breakpoint in it. That all looks fine. So you can see what I'm doing here is I'm generating a new payload reverse named pipe, and you can give it a pipe host and a pipe name, and that tells the stager which name pipe on which machine to attempt to connect to. It's classic executable format, and I'm sticking it in a place where I can copy it. So on my machine, because I don't really give a shit about OPSEC fails, I'm just going to come down here and copy that over, and we should be good. Excuse me, I'm battling a cough at the moment, and it's unpleasant. Right, so what we'll do to begin with, I've got those two, and I need, where's my other one? This one here. So this is the classic sort of Meterpreter stage. I should be able to invoke this, and we should be able to get a session. Okay. Now, in order to create a valid pivot, at the moment I haven't exposed the command to the UI. Oh, you're such a legend. Thank you very much. My lovely wife has just brought me a cup of tea. What a champion. What we need to do is drop into IRB, and we need to kick off client.core.generate reverse named pipe, and we have to give it some options. So actually, is that what I wanted to call it? I think I'm looking at the wrong thing. Create named pipe pivot. I'm hopeless. Create named pipe pivot. The options we're going to give it are, give it pipe name, which I think I had been using just pipe test. Pipe host, no, we don't need to give it pipe host because it will default to sort of listening to itself. That's what it should do. I don't even know whether I've added the code for that, so let's make sure we put that in. Oh, that should have an underscore or not. I'm copying that from this side over here, by the way, you can see. Pipe host is 10.1, 10.1.10.56. And what else do we need to give it? Pipe name and pipe host. Oh, architecture. So we can give it the arch of arch x86. Now I think that should do it. Might move this over just a little bit since I'm streaming and screen res is a bit sensitive. So when I invoke this, there's still some debug output that's going to come out if everything works appropriately. Ah, look at that, it doesn't. It's probably because of the stuff that I was mucking around with before. Maybe that should be arch with an H. There we go. Okay, so you can see I've received a response that says that everything's good. So we've added this pivot, right? So if we go back over here, we should see, thanks to Process Hacker, show details for all. We've got 32 Met TCP, and under here you can see we've actually created the named pipe. Now the important thing to bear in mind at the moment is the named pipe security is set up so that everyone only has read access, system has full, I have full, administrators have full, but anonymous only has read. So that means that only authenticated users, yeah, thanks mate, I did finally pick up on that, the architecture misspelling. So the security for this is a little tighter. I'll demonstrate it in a minute with a different named pipe under a different context so that you can see that everyone is set to full control. Excuse me. Just while I've got you here too, if we look at the token, you can see that we don't have the security privilege. Okay, we've only got a very small number of privileges. Right, so what I'm going to do is I'm going to kick off a excuse me, I'm going to open the stager that we generated, which was pipe test CC in WinDBG. All right, Brent, I hope you're paying attention, mate. This was the thing yesterday that was just baffling me, okay? So here's our breakpoint that we reached. This is the one that we set. So we're right at the beginning of the payload. And for those people who have never actually seen a stager in progress before, I'll explain as we go. So this is a fairly standard start. Step one is just to clear a bunch of flags, and then we call into ourselves. So we're doing a call to jump over a big block of code. So if we call and step in, we'll see the next thing we do is pop the value on the top of the stack, which over here, as you can see, is 20007 into EBP. That is a pointer to the block API code. So the block API code is what Stephen Fewer wrote yonks ago that allows us to invoke arbitrary Win32 functions just by specifying a hash. It's really, really clever stuff. So now with this code executed, EBP now contains a pointer to the block API, and so we can set up calls and then just call EBP, and we end up with Win32 functions being called for us. It's like magic. Okay, so if we continue on, this first part of the call is creating, what is it actually creating? This is doing I think it's doing create file. I can actually show you this. If we go back over here to reverse named pipe code. So the first thing that it tries to do is it tries to call kernel32 create file A. Okay, so it's setting up a bunch of stuff. And you'll notice that what it's doing is it needs to be able to get the name of the pipe, and we inline the name of the pipe here in a little bit of magic. And so in order to get it on the stack, we just call immediately following the location of that pipe, and a pointer to that location in memory is pushed onto the stack. So we end up having a pointer to the named pipe name shoved on the stack. We then call create file and make sure that everything works appropriately. Okay, so let's just quickly go through that. We're going to go over that. See, there's call to BC. So I'm going to step into that call so that we jump over the top of stuff. And if you look over here, we've got an address 20 blah blah blah. I'm going to take a copy of that. And if we look at that location in memory, you can see there's text there. So what if I do? I can't remember what it is. Is it just S or DS? Maybe it's DS. Let's see. No, it's not DS. It is... No, it's not DU. DA? It's DA. My WinDBG is terrible. There you go. So you can see there's the string as we predicted, sitting in memory nicely. Okay, so then the next thing that will happen is we're going to attempt to call block API with all of that magic. Now, before I do that, what I'll do is I'll open up debug view here as administrator, and we should be able to see debug output from our existing session as soon as we invoke this function call. So if we press N, we can see that EAX has returned F4, so that's not -1, which indicates that we've got a valid file handle. And going back to debug view, we can see a bunch of stuff's happened, right? Creating a new server instance, blah, blah, blah. So we have a result with 0 bytes. There's all kinds of magic you need to know about name pipes to get it to work. And here we can see it appears to be a new connection, so setting up a new context to replace the existing context. And we skip over some other stuff. The SE set security group was not enabled and is now disabled. I think that's a lie. I think my output there is incorrect. So the next thing it does is on our new code, it writes 4 bytes. So you can see here, sending stage on new connection. So what it's actually doing is it's taking the stage that we generated in Metasploit that we've actually pushed up and associated with this pivot. And it's writing the first 4 bytes, which indicates the size. And then immediately after that, we'll see very shortly when I've stepped a bit further, you'll see it's going to send the rest of the payload. Okay. Okay, so carrying on, we just go to the next function call, and the next function call is read file. Okay, and here you can see we're reading 4 bytes. We actually want to read the total size of the stage off the wire. We should see that, I think, in which location? 6C, maybe it appears in here. Okay. No, yes, there. Sorry, the one above. 34043. So that's read 4 bytes off the wire, as you can see, and it's put them just here. And that gives us the size of the payload that we're looking to read. Okay. So we push on, and we can see that in just a second when we dereference ESI, ESI contains the total size of the payload. The next thing we need to do is we need to allocate some memory in which to store things. So this is just doing a virtual alloc call, which will return a pointer. You can see this pointer here, right? And we shove that pointer in EBX. What I'm going to do is I'm going to write this to our little memory area here so that we can see anything that gets written to this block. Okay. Now, the next thing we do is what we actually want to do is we want to read more bytes. But the problem that I had was, skip past this stuff here. So originally, we've just done the virtual alloc. This function here didn't exist. I've chucked this in to try and make things work, okay? What we did have before was this function here minus the pop ECX. So what it does is it creates a spot on the stack in order to read however many bytes gets read off of the wire, and then pushes up a null pointer for this overlap flag, which we don't care about at this point. We push a pointer to where we want to read the number of bytes. We then we push what we did originally do was push ESI, which I'm not doing at the moment, but ESI contains the number of bytes that's left to be read. EBX contains a pointer to where in the buffer we want to write to. EDI contains our file handle, and so we call kernel32 read file. What was happening was, behind the scenes, when we were calling read file, it was actually reading in the full payload in one go. But this LP number of bytes read was coming out different. It wasn't actually saying you've read the full payload, it was only saying you've read like a fixed number. It was hex 1 followed by 4 zeros. So I'm going to demonstrate that now. So this block of code here is me calling peak named pipe to find out how much data is available on the pipe. And then what I do, ignore this horrible little jiggery pokery, we'll probably fix this later on, but ECX contains the number of bytes that peak name pipe said is actually on the wire. Okay? And then from there I say actually read however many peak name pipe returned, And that doesn't actually do anything other than flush data out of the named pipe, because we've actually already read it up here. Okay, so here I'm saying give me whatever data you can give me, and we'll see what that does. Let me go back over here. So we'll do the peak name pipe call, and here you can see there's the start of the PE header, right? Just like magic. Now if I add the value 3 so this is the tail end, right? This is the tail end of the payload here. And you can see this block here is the configuration block. Okay. Now what I want to be able to do is modify this value somehow, because I want to demonstrate how this works. Just give me a minute. I'm going to go. I can never remember how to do this. WinDBG right. How do I do that? Unless someone who is watching editing memory. There we go. So we should be able to do something like, let's take this value here and go edit a address. This is a really long string, strong, that overwrites some areas of memory so that we can see other things change. There we go. So I've just clobbered our configuration block with just a random bunch of crap. And I'll show you why I'm going to do that. So let's put this address in here so that things don't jump around. Now, the next thing I'm going to do is we're going to move on. We're going to set up a call. This actually calls read file. So in the documentation of peak name pipe versus read file, you'll see that peak name pipe actually behaves pretty much exactly like read file, except that it doesn't officially read any data off the wire. So you can extract information and write it, but it doesn't change the file pointer, so to speak. So the data is still there ready to be read. Okay. Now we're doing read file, which should actually behave in exactly the same way, but actually modify the file pointer so things move forward. Now, this bit's really important because 5C, so see this, I think it's this pointer here. This value here should contain the number of bytes that were read off the wire. And because we know that the full payload, i.e. 34, whatever it was, 34043 or whatever, is actually on the wire, we should be able to read all of it, right? But hopefully it's not going to prove me a liar. What are we doing here? So I'm actually, that's right, I'm actually ignoring, what am I doing? I'm actually ignoring the value that came out of read file, but there it is there, 5C, see that? Hex 1 followed by 4 zeros. So read file is telling me that it has read only, it's only read hex 10,000 bytes, okay? Now the payload itself is 34,000 bytes. And the window that we've got sitting up here is towards the tail end of that. So I know that we are well beyond hex 10,000 bytes, right? But as you can see, our configuration block has come back. So it has actually read the data off the pipe, all of the data, while only claiming that 10,000 hex bytes has been read. This has been baffling me for a day and a half now. I have no idea why it's doing this. So read file documentation says that this pointer should contain the total number of bytes that were read from the pipe, and it's not. I don't know whether this is specific to Windows 10 or something else, but it's completely baffling me. But this is why I'm doing a peek first to get the actual number of bytes and then trying to read that before and completely ignoring read file. If I could avoid the read file call at all, I would. Like I was hoping to find something like a set file pointer so that I could just skip over a certain number of bytes, because the call to peak actually reads the data to memory as well. So yeah, go figure. To answer your question, Brent, No, I have no idea why it's being done, but clearly something is going on that I don't understand. Something's going on that doesn't make any sense. And I have no doubt that it's me, but I'm probably going to need some help figuring out exactly why. Anyway, so from this point, we've read all of the data in memory, and you can see here there's a check. We go through a check to say we add the number of bytes that we read to EBX. So EBX again is the beginning of our buffer, and so however many bytes we've read, we want to move that pointer so that if we're going to do a looped read, then the pointer points to an area of memory we haven't actually copied any data to yet. But thankfully we don't need to worry about it in this scenario. ESI contains the number of characters or bytes we still need to read, and after this instruction you'll see ESI is now set to 0. So that says we've read the entire payload into memory. And then finally all we have to do is call ret, because prior to this block of code running we actually pushed a pointer to the buffer onto the stack, so that when we were done we literally just have to call ret, and ret will take us to the buffer. So ESP I think 64. So there you go, there's a pointer to our shellcode. And here she be. So I'm just going to hit F5 and let that run. And now you can see down here, Metsurf has actually kicked off. It's set itself up. It's parsed the name pipe URL. You can see here, connection already running on 244. So it knows that the named pipe handle that was pushed into the configuration block is valid, and it's now using that to do more. And so here it's going pipe packet receive, reading in the header. So it just sits there now on blocks and waits for any data to come in off the wire. So we're at a point now where we've got Meterpreter sitting in the middle. We've got a new Meterpreter instance that's connected to it via a named pipe. We've got Meterpreter served up the stage. The stage has executed and Metserver is now running, and now it's sitting on the named pipe waiting for more data to come in from Meterpreter, right? Now if we go back to Metasploit, excuse me, you can see here, let's full screen this. We have received a pivot packet. So this packet here says, hey, I've got a new pivot, which I'm probably going to change to something like pivot session new, so that we know it's actually a session. Now check this out. It's got a newly allocated session GUID. So Meterpreter is actually on the fly creating a GUID for that session and associating that session that it's received with that GUID using the binary tree that we wrote last time. Okay, so now what should happen is Meterpreter is saying to Metasploit, hey, I've got a new session here. And so we need to do some MSF side wiring that says, right, I've got a new session now. How am I going to keep track of that, and what should I do? And so the principle is that once we've received that packet, we go, okay, so this particular session that we've received that packet on should now become a pivoter. Okay, so it's got pivots associated with it. And I want to do this in a similar way to how channels work. And so you have like a pivot that runs under the context of the current session. But when that's running, it's actually got another session created under the hood that is also wired into all of the other areas of the framework. So you will actually have two sessions. But one session will be aware of the fact that it's a pivoted session. And so when a packet is sent or received, it knows that it needs to go via the pivot. The pivot will go, I know that I'm pivoting to this session over here. So it will take that packet and stick it on the transport of the original session and push that down the wire to Meterpreter. We've already got the wiring in place, though untested, that inside Meterpreter that checks the header of that packet and goes, hey, is that packet for me? Looks at the session GUID and goes, no, that packet's not for me. Let's go and look at the list of pivots that we've got. And if that pivot exists and we match that GUID to that particular pivot, then we just take that whole packet and pump it down the wire that's associated with that pivot. So that is where we're at. Any questions? I'm going to go with no. I've got the stream playing over here, which is why I can see the chat rather than having it on screen here. RESTful dev, that is an odd one. Yes, it is an odd one. I don't get it, because that exact stage used to work really, really nicely, but Go figure. It's probably going to require a little bit more debugging, and I might have a play with it on some different operating systems to see whether or not it is specific to Windows 10 or whether there's some other quirk that I need to work around. But that stager I know does work in production. There's a person out there who uses a lot of the new features that haven't even been landed in Metasploit Master yet by himself with his clients, and I have it on good authority that he's used the name pipe pivot, or at least the previous PR, with exactly that stager prior to doing the peak name pipe stuff, and things have worked. But that's a good question, Brent. Name pipe in byte mode are deprecated. I don't know. It's got to be something like that, because you would think that given that read file is pretty much always returning hex 10,000, that it's basically saying I'm only reading one, message. And I don't know whether messages have a fixed size, but according to the documentation we were looking at yesterday, the fixed size limit for a message is still well beyond what it is that we're doing. So it's like 64 meg or something, and that was on older operating systems. So yeah, I don't know. Maybe it is a bug. I've done a bit of research and I haven't been able to come up with the answer myself though. But very strange. But if anyone out there has seen what I've got going on here and has any inkling of what might be wrong, I would love to hear from you. It would be really, really nice to hear from you and get an idea of what's going on. Okay. Let's go back to Meterpreter for a second. So anyway, you can see that all works now. We're at the point now where that pivoted Meterpreter session is waiting for communication. So we need to get Metasploit to send some stuff out. Yeah, it needs to send some stuff out. So that's what we're going to do next. Now, before I push on with that, what I should do is we've got core pivot new written somewhere that I need to get rid of. So maybe what I should call as is session new. So here you can see this is where the connection comes in. Okay, we've now got an established connection. I look at the data that was sent along with the creation of pivot, and if they gave us a stage, then we need to stage it. So you can see these are the two calls: name pipe write raw. Give it the stage data size, which is 4 bytes, followed by the rest of the stage. Okay, and that's how staging works, right? That all of the stages know that the first 4 bytes indicate how long the payload is, and then it goes off and allocates memory, and then the rest is however many bytes, that we said we were going to give it. From here, I create a GUID, which I'll probably refactor out into some other more useful helper function. But for now, I'm creating a session GUID, which I'm using to associate the new sort of pivot with that target session. Now, we're in a position here where that target session doesn't actually know about this new session GUID. So what may actually happen, I don't know whether Meterpreter will do this on behalf of Metasploit, or whether I'll get Metasploit to do it. But Metasploit and the pivoted session now both need to know that the session GUID was generated here. So you see here I create a packet and I add the session GUID to it to say, hey, I've got a new session here that's associated with me, and we send that back down the wire to whatever the current connection is at the other end. And as soon as I've done that, we need to create a pivot context. This is the context that lives inside the binary tree that we created before that's associated with the whole remote instance. We set a server context inside that state so that we know when callbacks come later on, we know exactly which context is associated with that pivot. And then what I've got is this handy packet write pointer, which will probably add more pointers to this a bit later on. But packet write basically says, hang on, let me show you the deck. You might even remember from the last stream. But packet write is a function pointer that says I'm going to give you state, which will wrap up the pivot context, not the pivot context, sorry, the transport specific context, followed by a pointer to some data I want you to write and the size of the data that I want you to write. So what that enables us to do, let me just show you. back over here inside our transport, you can see when we've actually read some information off the wire. So this is it parsing the header. This is it parsing however many bytes. It's just making sure that we've got a full packet. And then the first thing it does is it says, is the GUID null, i.e., are we effectively a stateless connection, or is the session GUID our session GUID? If it's our session, then we just go ahead and decrypt the packet and off we go. This decrypt packet function modifies this packet pointer here so that the data that came off the wire is actually transformed into a valid packet instance that's fully decrypted, and that's then sent through the command dispatches. But in the case where we have a session GUID that doesn't match our current GUID, what we need to do is go and find the instance of the pivot inside our pivot tree that has the same GUID as what it is that's come in from that packet header. And if we find it, then we just get a reference to that pointer that's associated with the pivot context and say, right, this packet's for you. Please go and write this data down whatever transport it is that you've got. Now note how there's no detail here whatsoever about named pipes, because we don't want this area of code to have to figure out whether it's a named pipe context or not. We just need to say, hey, you need to send this data. And then behind the scenes, because that packet write pointer is referring to a named pipe instance, and the state has a copy of all the named pipe related state, if we go back to our pivot named pipe, you'll see all that happens is we get our named pipe context out of our state, and then we actually do a looped write. You can see I've got some debug code left over here from me. I was trying to send things in chunks. I'm not doing that anymore. So that will just sit there and pump the bytes out until it's done. And we're already using this code to send the stage anyway. So we kind of have this means of a given transport to receive a packet, analyze its header, and then just pump the packet out to whichever session happens to be associated with it, regardless of what kind of transport it's using. Okay, is programming still needed to create a video game? That's beyond the context of this discussion, I'm afraid, Robbie. But I'll let other people answer that if they want. But I would argue if you want to make a decent game, you're going to be coding, and that's coming from an ex-game developer. Good games are coded. Bad games are dragged and dropped with JavaScript GUIs. Right. Okay, so hopefully everyone's now got a decent picture of how that all fits together. So we're going to have to go back over here now and start mucking with this stuff. So, like I said, what I want to do is have something here that kind of mimics the way that channels are handled. So, I think what I did before is I had a pivot container. So this was the beginning of the pivot container. So what I did here is I mimicked what the channel code was doing before, and I've created this pivot container, which is an inbound packet handler that is able to handle inbound requests that have come from Metasploit. And so all I've done here is I've said, if the packet method is whatever, then hey, we know we've received a new pivot packet. So that is what has called this piece of code here. We can see that the packet has actually made it to this pivot container. But if it's a new pivot, then we need to be able to manage that pivot internally through some kind of collection of pivots. So what I'll probably do is we're going to have to refactor some of this code, and I'll do something very similar to what the channel stuff is doing. I'm going to rename this so that it's an actual pivot, and there'll be a separate pivot container class alongside it, much like what the channel. So the channels have a channel container and a channel, and the channel thing kind of works like a factory and produces channels based on messages that are coming in, etc. There's also a function in the channel that allows you to call like channel.create in code. So that allows you to create channels remotely, as well as having the remote end being able to create channels locally. So in our case, it probably makes sense for us to separate logically what I believe to be 3 separate things. First is a pivot container, and that is just basically a very small piece of code that allows us to track session GUIDs versus instances of pivots. Okay, so that's what that pivot container thing means. There's the actual instance of a pivoted session. That pivoted session is the thing that keeps track of which session, like creates a new session and keeps track of that session as a pivot point, and deals with the packet routing appropriately. And then there's the third thing that allows you to create a new pivot, which is neither a pivot container nor a pivoted session. I don't know whether it makes sense to maybe create a different class for that. Maybe it's enough on the pivot container to just go, I want to create a new pivot. But, we'll get to that. Okay, so in order to mimic stuff that we were doing before, I'm going to create a new pivot class, and it's going to look a lot like this. Okay, so it'll be a class pivot, and the pivot itself is going to see this was copied and pasted from the channel code. Class modifications to support global pivot message dispatching without having to register a per instance handler. So I thought, well, that's exactly what I want. I don't want a per instance. Oh, actually, do I want a per instance handler? Let's have a think. I probably do, because pivots are specific to sessions. But then again, channels are specific to sessions as well. Interesting. Anyway, let's just sort of follow the path. Excuse me. Of what the channels were doing before. So you can see we've got this channel container. So I've just read that in. Oh, I edited it. So you can see all it's doing is it's a very dumb container for adding and removing channels, like a local dictionary. But I think what we effectively want to do is exactly the same as this, right? But with pivots. So we need a pivot container, which is this, meant to contain 0 or more pivot instances in the form of a hash. Let's go and do the search and replace. CFL initializes the pivot association hash, adds a pivot container, pivot identifier, pivot. Now that pivot is going to have a session GUID. It's not going to have a CID. Oops. Pivot. Oops. Session GUID. So we're going to do everything based on session GUIDs. Have I got any more? Yeah, I do. Channel pivot based on its identifier, self pivots, hash of pivots. Copy and paste coding at its best. Okay, so now we want to modify the client so that it knows that it's a pivot container. Who remembers click and play? Atwolf, do not mention click and play. Oh, hey Menz, how you going, buddy? Thanks for coming along, mate. Haven't seen you in a while. Alright, so back to our pivot class. We're probably going to need an accessor, which is a session GUID. We're also going to be keeping track of maybe I should be more clear, like which session GUID is it that we're talking about. So we've got a reference to the client. That client is the one that the pivot's coming through. So maybe I should call that pivoted session GUID. Yeah, let's call it that, which means that that stuff needs to change. Yeah, that's better. So that removes the pivot. That's no big deal. But I just thought it would make a little bit more sense. Maybe what we need to do as well is it adds a pivot at the container and is indexed by the session GUID. No, let's call it the pivoted session GUID. Looks up a pivot instance based on its, what do I call it, pivoted session GUID. Removes a pivot based on its pivoted session GUID. Okay. Now that doesn't look too bad. Pivot container and the pivots. Okay, so we're going to do some more magic in here in just a minute. What I need to do is I can go back in here. So where was it? No, it's not in here. Maybe it's in. Let's do the grep thing. Need to exit out of these sessions anyway. It's in client. Lib. Ooh, what have I done there? Lib rex post meterpreter client.rb. That one there. Okay, so I'm going to rename that to plain old pivot, but we need to change this to pivot container. So the class, the actual instance of the Meterpreter client / session, client and session are not necessarily completely interchangeable, but there are some subtle differences. In some cases you refer to client, in some you refer to session. In fact, this is something that I hope that we can get time to address, because in certain cases there's a need for one over the other, and when you're doing exploits you should refer to client, and when you're doing auxiliary modules you got to refer to session or something. Don't quote me on that. I've probably got that completely wrong. But yeah, anyway, so what we've done here is we've extended our client so that it is now a pivot container, and we've added pivot inbound handlers when we have a new session come in. So this init Meterpreter basically says, you know, we're initializing as a result of a new session being established, and it's doing a bunch of other magic wiring. And along the way we need this to have the ability to handle channels, and now the ability to handle pivots. Channel and pivot inbound packet handlers, plural. Okay, so with that in place we should be able to simulate exactly the same things we've just simulated and not have any breakages in Ruby. That's the plan. So fingers crossed that this kicks off like we want it to. Yep, no breakages there. Oh, go away. So we'll kick off the Meterpreter session. Okay, that's looking good. Where's our client.core.create name pipe pivot? Oops. Should actually talk to the session first. There we go. And then we should be able to do pipe test without the breakpoint. And what happened? Nothing. Or maybe it does have a breakpoint in it. Maybe it just crashed straight away. I wonder if I still had a breakpoint in here. Yeah, I did. That's why. And going back here, so there you go. We have a received pivoted packet inside our new pivot class. Okay. Okay, so that's good. We have the ability now to route those packets to the pivot. We now need to be able to create a new instance of a client at this point, don't we? So what I'm going to do, let's have a look at the channel code. Let's see what the channel code looks like. There's a lot of magic in here that I don't understand. So, no channel, context channel may not be registered yet. Call the channel stereo handler. So you can see there's a lot of stuff in here that I don't quite understand. Creates a logical channel between client and the server based on a given type. So this is the kind of wiring that is used for basically all things like port forwarding and large file downloads and all that. When you invoke a shell behind the scenes, this is actually using this functionality. It creates a channel between one end and the other, and then data is basically shuffled back and forth using TLV packets. Making pivots a first-class citizen in sessions. Yes, Smubix, that's what we're doing. We're going to be able to invoke a pivoted session and have appropriate metadata inside the client instance that allows us to keep track of those pivots. And hopefully this will give us the means to be able to say that this pivot is associated with this session, and therefore that session is associated with a current session. If that current session goes down, we should be able to tear down any associated pivoted sessions as well, so that we don't have that messy scenario where we're unable to tear down sessions because we don't have any kind of correlation. Yeah, Brent, there's a lot of old Ruby code in here that I'd like to see the end of. But I think this chunk of work is going to result in enough code churn, so I might leave that to a future PR. So what I'm trying to figure out here is, because we can create channels in both directions, we can create a channel by launching code in Ruby and say, hey, I want you to create a channel at that end, and we can create a channel in the opposite direction as well. Or can we? We can create like a server instance, like a listener. Yeah, I don't know. But in this case, we've got the situation where when we create a pivot, we just create a listener. And then when a pivoted session comes in, we need to create a whole new session that's associated with the pivot. So it's kind of coming back out of Meterpreter and kicking the process off that way. But what I think I should do first, let's move into something a bit more useful. Do I call it initialize or new? This is where my Ruby sucks. Create. It doesn't really matter. We'll call it create then. Pivot.create. So I want this to do what we were doing inside. Is it client? No, it's in client core, isn't it? Yeah, this bit here. So this create name pipe pivot. Basically, I want to do the same as that, but inside here, so that inside code we can go pivot.create and have that associated with a particular client. Okay, so same story, right? Okay. Now here you'll see this is definitely hard-coded to name pipes. I'll abstract this down the track into something a little bit more useful. So I don't even know whether we might have a name pipe pivot class. But at this point I'm just going to stick to what we've got here. Now does the channel code do all, yeah, it does do all the TLD stuff. Yeah, okay. Okay, core pivot add. So all I'm going to do is exactly the same thing. I've just got to make sure that the includes that are required exist in this context. So first thing we should do is self.client equals client. So we keep track of the client so that later on we can do exactly the same thing. I'm actually going to remove this or comment out this initialize here because we're not going to be using that just yet. Excuse me. Okay, so we know that the client is a pivot container, but at this point I don't think that makes makes any, we don't really need to worry about it. I'm going to leave that like that. Let's see, response. What I'm going to do here is just leave a to-do note. Check the return value. Because what I think we should do at some point is make sure that the return indicates whether or not it's a full-fledged pivot or not. Because at least in the context of named pipes, we want to know whether anyone can connect to it or whether only a subset of people can connect to it. Would you be able to have one session that is pivoted through one instance, auto re-established through another one, if told that it could handle it, sort of like a transport add pivot session 2. So basically, Movix, the way that I'm intending for this to work is, let's pretend that the primary transport between the pivot, not the pivoted session, but the pivot point. So let's say we've got MSF, we've got client A, which is the pivot point, and client B pivoting through client A. And then the transport between MSF and client A disappears. So we lose 2 sessions, but the connection between these two is not lost. What I would like to see happen is when this reestablishes, client A will connect back to MSF, and then as part of that initial connection, Meterpreter will either tell MSF or MSF will request to know which pivoted sessions exist on the target. And so basically here, give me a list of session GUIs that you've currently got, and if I know about any from before, I'll do the rewiring. If there are new ones, I'll do that wiring as well. I guess the bonus in this scenario is that if we have Meterpreter doing the staging, then it can still stage connections while the transport's down, which is kind of interesting. Metasploit development is so much better with an Aussie accent. Yes, I would argue that Metasploit development is better with any accent that's explaining how things work. But yeah, so Movix, does that answer your question, mate? I'm hoping that it will, like the aim here is for all of those sessions to reappear without you having to say, hey, I know there's another session on that transport. We have the ability right now to know when sessions are reestablished. We haven't quite got the metadata in place to say, hey, I've seen you before because your GUID matches something that I've already seen, but we'll get to that. But at least when those sessions, when that session gets reestablished, those sessions that tag along with it should get automatically wired in as well. That's the plan. Okay, so core pivot. This will be session new. Okay, so now I'm going to leave that packet inspect in there. But what I'm going to do is go client dot, what do we call this again? Pivot container, add pivot. Add pivot. Pivot. So the question then is, what does the channel stuff do at this point? Find channel. Channel map, not a valid channel context. So what I want to be able to do here is associate, effectively create a new pivot instance. Need to think about that for a sec. Have you got older video streams to look at? Your explanations are good for those who don't know some of the context-specific terminology. All I can say, RESTful Dev, is that I've got some stuff archived on YouTube, but it's a hodgepodge of stuff. So there's some Meterpreter stuff. There is a live stream there that talks about how to build an extension or how to add features to Meterpreter and whatnot. But there's nothing that really goes end to end as far as Metasploit goes, and part of the reason for that is because I don't know how everything works. I don't even know if anyone. The closest thing to that might be Egypt or Sinner, but maybe if they were here and commenting, they would admit that they wouldn't know everything end to end too. I think MSF is now big enough to say that no single person knows absolutely everything about it. All right, cheers, Dar. Thanks for coming along, mate. Okay, so create a new channel instance. So that initializes this. Okay, so we're going to have to do something pretty similar to this, I think. Yeah. So we want callers to invoke this, and that will return a new instance. But do we? This is where I'm trying to make sure that we separate the notion of a pivot versus a pivoted session. Like here, we end up with a new pivoted session, right? Not just a pivot. So I don't want to create. Like what we're actually doing here is creating a listener. Now, do we need to be able to keep track locally of pivot listeners? No, I don't think we do. Not at this point. Although we might want to turn them off down the track, but I think we'll get to that later on. So initialize, and we want to give it the client. We probably want to give it the session GUID as well. Yeah. Pivot session new. So we should be able to go pivot session. Oh, we just call it pivot. Pivot equals pivot.new. Is that all we do? Pivot.new? Yeah, I would assume. Pivot.new, give it the client, and give it packet.get TLV. Get TLV value? Let me just get TLV value. TLV value, sorry, TLV type, session GUID. Then we can go client. Actually, do we need to do that? Should we do this in the constructor? Probably should do it in the constructor, hey? So down here inside our constructor, we can say self.client.add pivot self. I don't know whether or not that's the kind of convention you like to see in Ruby or not, but yeah. Okay, so I can answer that question. I'll just say Dade or Dade. This is Guy Barone's pattern 239. Let me see if I can find a way of pasting that into the chat for you. Twitch.tv Colonial. Excuse me. I'm not signed in to. See, I'm just pasting. I can't sign in anonymously. Okay, just give me a sec. I'll find a way of getting it off this machine. Look, if you go to SoundCloud and search for Guy Barone, which is G-A-I space B-A-R-O-N-E, he's got a series of patterns, and Dade's sufficient. Awesome, dude. So yeah, search for Guy Barone, have a look through his list, and you'll see Guy Barone patterns 239. 239 is the one I'm currently listening to, and we're about 12 minutes in. So yeah, it's pretty cool. Easy, cruisy tracks. Right, so anyway, back to what we're trying to do. So that sets up stuff. This keeps track of local pivots. Once we've actually created that pivot, this is where we need to start establishing a new session. And this is where I'm going to get a little bit lost. Brent, if you're still around, I'd love to get some insights from you as to how you think we should do this. Exit out of this stuff again. I would assume that there's like a session.new somewhere inside lib. Nope. Or is it client.new? Technically, are they any different? Client.new, session.new. Oh yeah, I should have done better than that, shouldn't I? Core handler. Whereabouts is the code that actually creates an instance of a new session? Is there a create session? Aha. Create session inside handler. Okay, let's see what that does. lib msec core handler.rb, create session. What does this do? If there's a parent payload, otherwise, if the payload we merged in is an associated session factory, allocate a new session. Aha. Otherwise, okay, this is something that really confused me to begin with. There are a bunch of different session types, and behind the scenes, this session variable here is actually not a session, it's a session class. Where is it? So we're actually conflating some stuff here. So session lib grep to, what am I looking for? It's attribute accessor, right? Exploit driver, that's not it. Web session manager, simple sessions, exploit driver sessions. There it is there. Core session.rb. Lib msec core session.rb. Okay, so where is it? Is that it there? No, that's not what I was expecting. And this is part of my problem while navigating the Ruby code. I'm really not sure what it is that I'm looking at and where, because somewhere there's a session, and the session isn't actually a session, it's a session class that is used as a factory, which is what we were seeing just here. So there, because session refers to a class instance, it's actually creating a new instance of a session based on that class. And as part of a PR I did a while ago, it's modified that session variable so that it actually said session class rather than just session. Needless to say, that was a scary change. But anyway, this is interesting because this is dealing with an instance of what? Handlers. So I need to find a way of being able to invoke or create an instance of a handler. No, not a handler. I need to directly create a new session based on the type of pivot that was created and listen. Yeah, bugger. If that's the case, what are we going to need to do? Why are they no call session factory? Okay, so the problem with this is because, okay, so this is kind of how it works. You've got a handler, and the handler knows what kind of session is associated when a new connection comes in on that thing. Let me see if I can show you. It's not in here. Modules, payloads. Excuse me. Let's go stages, Windows, reverse TCP. All right, so see here. This line here basically says the handler that I want associated with this payload is the reverse TCP handler. We also know what kind of payload this contains, and I think inside, I don't know whether it's the handler or not, but let's have a look. SF or handler, can't type. Handler.rb, handler reverse, for example, reverse HTTP. Where is it? Maybe it's not there. We'll come back to that. Oh no, it's the stage, isn't it? Modules, stages, Meterpreter. Windows Meterp. Here we go. So you can see here that this thing here has a reference to the MSF sessions Meterpreter x86 win. So maybe what we need to do when we're creating the pivot in the first place is we need to, on the fly, figure out what kind of session it is and associate that with whatever it is that we're creating while keeping track. So that means back here in our pivot container and our pivot. So this thing here, we create a new pivot here. We need to be able to figure out and keep track of what pivot was associated, what stage was associated with it, and i.e. what session is associated with it. So, do we expect an identifier? We need a way of being able to tie what we created in Meterpreter to what happened in MSF. So when we spin up an instance of a named pipe on the target channel, on the target Meterpreter instance, we need to be able to keep track of that, because when a session comes in, we need to be able to say to MSF, hey, I've got this session based on this GUID, and it's tied to this particular pivot thing that you created. Because we don't actually want Meterpreter to know anything at all about the architecture or anything like that of anything that it's talking to. It just needs to send the stage that it's supposed to send. So what can we do? What can we do about that? We're probably going to need to have some kind of identifier in Meterpreter that is returned when the pivot itself is created. When that pivot's created, we return a reference to that sort of pivot listener, so to speak. That pivot listener has an identifier. And when we create the pivot listener, we give it the identifier, we give it the architecture, we give it the session type and all that kind of stuff. And then what we do when the first session comes back in, we can say, hey, we've got a new session on this listener. This listener has this identifier, and here's the GUID for the new session. We send that down the wire. Then, when we get back into this area of code here, we can get the session GUID and the pivot listener identifier. We can look up the pivot listener type and create a new session based on that type. GUIDs should be tracked to session type. Yeah, but we're actually creating GUIDs on the fly outside of MSF at this point, so that we can do our tracking of pivoted sessions on the target. And we also might be in a situation, Movix, where we've got multiple listeners for multiple architectures, and we need to know what is coming in session-wise on what. I suppose maybe what we could do is we could use the multi. Maybe we could use the multi-session type. Libcore sessions. Is that where it was? Lib. Oh, what was it called? A multi-payload. Oh, no, I didn't do anything with multi-sessions, I don't think. Multi-pipe rep session. Whoa. Session. Yeah, I guess I didn't. This was actually the issue that I had while trying to set up a multi-handler, multi-session kind of thing for TCP. So now we've got a sort of like a multi-payload type on HTTP that checks the UID and says, oh, this is a Java payload, so I'll send you a Java stage. Can't do that with TCP at the moment due to the fact that being able to sort of separate ourselves from TCP and say, oh, we're actually now HTTP is proving to be a pain in the butt. Ah, there it is. libmsf base sessions. Thanks, dude. That's awesome. libmsf base sessions multi. Right, here we go. This class creates a platform-independent Meterpreter session type. Check it out. So see this requires a UUID. Fascinating. Fascinating indeed. That makes a lot of sense. One thing that is a little bit of a concern though is that we've got this stream. I don't even know what this stream is. And now let's return generic basic functionality. I think this is exactly what we should be doing. We should be using this multi-session thing. And basically saying create a session based on these options. So we're going to need to get, in order to use that though, we're going to need to pull out the UUID. So if we're going to pull out the UUID on startup, before we even create the session in MSF, we need to extract the UUID from the payload. Question then is like, so right now we create a new stage and it has all the transport config and whatnot in it. We just send that blindly down the wire. Perhaps at this point what we should be doing is creating a UUID separately. Thing is, that UUID is going to be different. But I suppose there's at least enough to kick things off. So much stuff to keep in my head. Do we take the path of keeping track of which type? I don't think we need to do that if we just somehow get the UUIDs out. In order to get the UUID out of the target, there are two ways of doing it, I think. I'd be open to hearing more suggestions. Mubix, Brent, whoever is listening. First one is when we generate the UUID at the point that the stage is created, we also take that UUID out and we tell the pivot creation code separately that the UUID associated with this endpoint is something. And then when we send that initial packet in with the session GUID, we can also give it the UUID. If not, then the other way is once that initial connection has been made, we can request the UUID directly from the Meterpreter session that has been pivoted. But then we actually have to start intercepting traffic by saying, okay, I've just sent a request on behalf of these guys over here to get the UUID out. And then as the packet comes back out, we've got to go, hang on, is that something that we wanted? So I don't think I want to do that. By the sounds of it, UUID probably makes the most sense at this point. So maybe we should do that. If we keep track of the payload UUID and we send that as part of the pivot, which also operates as an identifier, then we have the ability to tie things together in sort of one fell swoop. So unless I hear otherwise and people complain, I think I'm going to go and do that. Any thoughts? Will storing the UUID in memory of the pivot, will it survive an MSF restart? Will any of this survive an MSF restart? Okay, let's have a think. Yes, it will. So the aim as far as the session GUIDs is concerned is to eventually actually put them in the database so that we can persist long-term information about the session. The UUID, thankfully, is effectively persistent because the UUID itself has all of the information in it we need to know what type. So, we actually have one problem. Anyway, let me answer your question directly, Movix. It would survive a session restart because the UUID that is associated with any particular session, it has the platform and the architecture in it. And given that we're not sort of keeping a dictionary, so to speak, of UUIDs against... we are actually keeping a dictionary. But the good thing is that it's stored in Meterpreter as well. And so when a new session comes in, we give it the UUID in the session GUID. That UUID basically can say, that is clearly a pivot that we didn't know about. The only difference, I guess, is that the UUID itself wouldn't have any clue as to whether or not it was a named pipe pivot, but does any of that matter? I don't think so. I think we can quite easily make this stuff survive an MSF restart. The stuff that requires persistence is pretty minimal, really. I mean, if we're just keeping a local dictionary of pivot points, we can make it self-heal on restart. So, when a message comes in through a pivoted session, we're like, okay, we don't actually have a pivoted session associated, so maybe we should just literally go and spin one up. Excuse me. But right now what I want to be able to do is extract the UUID from the payload before it goes out on the wire. Hey null 513. Yeah. There's always so much more to worry about. Getting hit up on chat. Okay, so thoughts? Is this a Facebook hacking script? No, it absolutely is not. I don't know whether we would store that kind of thing in config in that location, Movix. I think this kind of stuff should probably persist in the DB. And given that we're looking to put payload UUIDs in the database itself, it's probably fair to say that we should be able to tally that up on the flip side when things restart. The only concern that I've got as far as breakage is concerned is when you have a pivoted session that's say 32-bit and then you migrate to 64-bit, the UUID clearly changes. We don't have a way of marrying up that changed UUID. So maybe we do need a separate identifier or a means of extracting that UUID. In fact, that's probably what we should do before we do anything else. Hey, Null, keep it down, buddy. We're not here to be... I need the Ranger back for some trolling. Oh, yeah, of course. Oh, man, I completely lacked context there. The Ginger Ninja is what you're talking about. Justin, the Ginger Ninja. Yes, we do need him back. Came to the party a bit late. What is AJ working on today? So rest whatever. I don't think we actually need to worry about having a compound key here either. If we just create some kind of identifier that which we know is consistent regardless of what the UUID is. or we have the ability to begin with to request that UUID. This is what I think we should probably do. There is... Oh shit, is there? There should already be something. Did I rip it out? I think it's in metal, but it's not in here. Because the UUID is being sent for every single packet that comes out. I have an idea. Before we do any client-side wiring, what we should probably do is have Metasploit send a packet down the wire with that session GUID. Oh, this does sound kludgy though, doesn't it? Alright, so here's what I was thinking. I was thinking that as soon as that new connection comes in, we can make a request with that session GUID straight out saying, give me your UUID before we even create a new session instance. And then whatever that UUID tells us, we can go ahead and create a new session based on that type and wire everything in. The problem that we've got there is a bit of a horse and cart scenario. Not horse and cart, chicken and egg. Chicken and egg scenario being that in order for us to send a packet on the wire, we tell the session to add the packet to the transport, and the session, when it does that, what happens? It passes in its own session GUID when the packet is converted to raw format. So basically says here, this is the packet that I want sent. Go and convert it to a binary format using, this session GUID and these other encryption details if encryption is currently in place. What we want to be able to do is have something with a separate session GUID do exactly that, asking for the UUID. And then we're back to square one again. So then I guess the question is it enough for us to, instead of just creating a, one of these abstract session types, maybe we can just create, a generic Meterpreter session? Do we need all of this architecture specific stuff? I'm thinking not. We need to know what this rstream thing is though before we can go any further. So let's have a look at that. Rstream sessions, interactive session. This music's good. Okay, so inside, where was it? No, this wasn't it, was it? No. Pivot container, was it here? No, just going to clear off some of this stuff. Handler. Yeah, here it is. So con is the connection. So that's the stream. Create session. So that's called from inside the handler, which I would assume is called handle connection and establish connections applied. One in, one out handles. Passes parameters. In this case, handler is capable of handling multiple simultaneous connections. Whatever. I think that is all that it's doing, isn't it? Parent payload create session. There's a create session. We have to use it. Yeah. Okay. Yeah, I know. It really is confusing, string versus con. So I think, let's see what handle connection does. I think handle connection varies as well. Let's see. So in reverse TCP, you get given a socket handle, which is a Rex socket handle. In reverse HTTP, you get given... What do you get given? Short circuit, the payload's handle connection processing. Okay, core handler reverse HTTP. Ah. Would you look at this? Isn't that interesting? So CLI, I believe, is the actual client that's being used to talk to the other end. So we will probably need to abstract that a little bit. But the rest of the stuff we might be able to get away with. Except for all this stuff. Where was create session again? Here. Opts is then passed down to whatever instance. So in the case of this, we might end up with a Windows. Right, let's see what this does. Excuse me, libmsf. Meterpreter x86 win. Let's have a look at this. Which invokes that thing on Meterpreter anyway, which is libmsf base sessions meterpreter.rb. Okay, so what options does it actually care about? Doesn't actually care about too much, does it? Init Meterpreter. We've seen that somewhere before. Can't remember which file it's in there. Client. There it is. Look at all this magic. Yes. Okay, so this is kind of what we're looking for. As long as we send through a bunch of things that, you know, make sense. Like we don't actually have to set any of this stuff. We can query these on the fly. We don't need a passive dispatcher or anything like that because that's not our problem. Initialize. We will always end up coming through here. Monitor socket. Maybe we would actually have to do something different. There's some duplication of code in here that I don't like as well. What would be nice is if we did something like this. And then we can get rid of all that. Hooray for removal of duplicated code. The orphan session stuff is very close to what you were doing with the pivots. Yeah. Yeah, I totally hear you. Hey, Jada. about the best way of moving forward with this particular bit of code, which isn't particularly pleasant, I have to say. What I'd actually like to be able to do is this monitor socket here, because this monitor socket code clearly comes from so it comes from the packet dispatcher. Now we don't actually want that code to run in this case. We basically want all of this stuff to come in for free. The only difference being that if it has an associated session. Right, so here we go. Let's see what we can do here. I don't want to do this unless we only want to monitor the socket if there isn't a pivoted session or a passive dispatcher. So unless there's one of those two, go ahead and monitor the socket. Initialize the passive dispatcher if there is one. Passive dispatcher is basically predominantly, I think, related to HTTP because it's not an active socket. Whenever I'm stuck on moving forward, I review what I've working so far. Yep, no, I hear you, Movix. This is doing grep initialize. Channel container. Huh. Probably need to do that too then with my pivot container. Yep, there you go. Alright, so I'm comfortable that if we create something in here, then we should be able to change this so that reference to a session to pivot through. So that can be blank. What I want to be able to do is to make sure that when packets are being sent, that the existing pivot is used. So that is what is it? Send request. Okay, so that would be lib msf request from Meterpreter. No, that's not it. Packet dispatcher, that's it. Right, so send request. So you see at this point what we've got when we call send request is we've got this send packet wait response. Then we call send packet. Send packet does all of the magic, see here. And then short circuit send when using a passive dispatcher. So when we wouldn't actually have that, it would always come in here. So the difference then would be, instead of just writing directly to a socket, we need to go actually send it down the neck of the associated connection. So if self dot pivot session, so if that's actually referenced, do that. Ooh, is this going to work the way that I would want it to? You don't actually need to do that. That's ignored. Why is it ignored? Oh, by it's written. Right. Alright, so what I'm looking to do here is this would be self.pivot session dot send packet. Actually, we need to do this outside of the context of this. So let's just undo that for a minute. Yeah, so we need to hijack it here and go self.pivot session. We need to return self.pivot session.send packet completion routine. It's a little bit wide, isn't it? So if we have a pivot session, then instead of doing everything that we'd normally do at this end, do it over on the pivoted session. Send packet wait response. So the question now becomes, if we send the packets out in this way and we call wait response, is it going to block expecting the packet related bits to come through? Because we send a packet and we wait for the response, we get a response packet back out, we end up chucking it on the queue. So for example here you can see I've got some inspection for another session. So at this point here I was going to do a check to make sure that excuse me. So receive packet, that's it coming off the wire, and then it goes into the queue. So once it's come off the wire, it takes things off the queue and then dispatches them from this backlog. And then just through each backlog it dispatches the inbound packet. So dispatching the inbound packet would result in packet response, notify response waiter for the packet. Aha, so yeah, maybe it would just magically work. Are you worried at all about timeouts over pivots? Yeah, I absolutely am, but I'm not going to worry too much about that just yet. What I want to do is just get the mechanics of it working, and once the mechanics of it are working, then we can start worrying about implementing a little bit more smart on top of stuff, if that makes any sense. Excuse me. Okay. I'm pretty sure that this is going to break stuff. What have I changed? Welcome home. Still going. That's all fine. So given that we actually haven't wired in any pivot session related bits and pieces here, I think what I'm going to do is start doing that now. So inside our pivot, we create a new pivot based on that session GUID for this current client. And to do this, we need to go client, add that pivot. Let's take this. And go self.session. So the trick here is going to become, we want the session to look at us to be the dispatcher for whatever it is that it's sending. Is that what we want to do? We need to give it some kind of communications mechanism. Have I added this? Pivot session, pivot session. So we're going to need some ops. And for example, one of the ops, which is pivot session, is client. So if that's the case, do we actually need to pass in something here? What would happen if we did that? Meterpreter. We don't need to worry about that because we're not dealing with encryption. Don't need to worry about that. Don't need to worry about that or that. Okay, so we could technically pass in null. But the packet dispatcher might expect more. We wouldn't get to this point, so that should be okay. What happens here? Monitor socket, we don't even invoke that. Receive packet. This could be an issue. But that's only done on monitor socket. So it's not an issue. How fascinating. Don't know what this would do. So what else do we actually need to give it? Probably give it this session GUID as an option. We would need to go like this so that we have a sane default for sessions that are new and haven't negotiated, and that would mean that, sorry, where are we? So once we've got our session set up, oh, I shouldn't call that, should I? Pivot session GUID. I'll call this the pivoted session because that's what it is. And I don't want that to be conflated with the idea of either a plain session or a session class as per used elsewhere. Yes, there is a reason for that, because we need to be able to look up based on packets. Although from what I'm seeing here, we may not actually even need to keep track of the pivoted session GUID at this point. Yeah, we will. We want to be able to remove that from our list of tracked pivots. So bear in mind, this is used for what's it called, Mubix. This is used for tracking of the pivoted session locally in metadata, and the session GUID here is used for making sure that the packets sent across the wire have the right session GUID in them. We do have a problem. Yeah, we've got a problem. So, going back to the packet dispatcher. Yeah, the packet dispatcher is going to need to know which GUID to use. So, for example, you'll see it here. Ignore the receive, look at the send. Okay, so when we send a packet, that send packet code will use its own GUID, right? We need to be able to specify a different GUID. Without waiting for a response. Yeah, okay. What I need to do here, I think I'm going to change this interface a bit so that we don't end up with too much pain. Pretty ugly. Maybe I need to do this. Just to make it look a little, whoops, a little bit nicer. So that gives us the ability, when we're sending packets, to specify a different set of options, which will allow us to take our current session key and encrypt the packet on the way out. Problem that we've got then is when we receive. So we've got to here, there's a from that requires the same. Receive packet. This is going to be a problem. When the packet comes in, we need to investigate the header before we decrypt it. This is the reason why we rec v before we do anything else, but we should be able to do that without a problem, because when we receive the packet, we already populate the session GUID. Rex post packet. So as we do, we should probably do this before we've finished reading the whole payload up. So we might need to expose a separate function that says parse the header. Force it at this point. Problem that we've got there though is we care about all of that other stuff. We can't actually re-invoke that in that way. Let's just prevent all of that noise for a minute. Go back to the dispatcher, because here we're calling from R in this location and in this location. This is from the passive request. Maybe we should call this dispatch inbound packet. And that doesn't even do it. Receive. Yeah. Yep. what I'm thinking is that we don't actually decrypt or parse the bulk of the packet at all until we dispatch it to the appropriate session. So def dispatch. Really? Yeah, right, okay. We need to have it done at this point. But they all come through here, so maybe what we should do is at this point check the header, and if there's a pivoted session, then we can decrypt the packet with that pivoted session key before dispatching it. Yeah. That's probably what we're going to have to do. Man, changing this stuff scares me. Alright, I'm going to take a breather for 15 minutes. Let's go and grab a drink. But I'll be back for those who are interested in continuing. I'm not even sure if Brent's still around, but yeah, I'd love to get an insight from him as to how he would like to see this happen, because I'm thinking patching it over the top of the existing session handling mechanisms might be a bit nasty. Yeah. When I say break, I don't mean a break from stuff that I got to do. I mean a break from streaming to you guys. If you think I'm going to go to sleep, you are mistaken. But yeah, I'm just going to turn off the mic. I'll be back in 15. All right, see you soon. All right. Let's do this thing. See you, Movix. Probably already gone. Okay. So now that I've been to the bathroom, I've said hello to my kids who've come back from school, and I've had some chocolate. Ready to go again. Right, so to do here. The concern that I've got at the moment is the whole request response mechanism. So when we say, hey, there's a packet going out, I want to wait for a response to this packet. So the packet gets generated, it's got a request ID and all that sort of stuff. It gets sent out to Meterpreter, it gets handled, and then a response comes back with the same request ID so that it can marry the two up. And then you know that that packet came back for you. With this mechanism, this is happening at the packet dispatcher level, right? There's this add response waiter. And this response waiter thing, as you can see, associated with the supplied request packet. So we're basically just sitting there waiting for a packet to come back in with the same identifier. Excuse me. And so when you find the appropriate thing that's waiting for that response, you then give it the packet and say, here's the packet that you're looking to wait for. This packet response waiter, how does that work? Lib packet response waiter. So notify completion routine. Okay, so if it's got a completion routine, otherwise self.response response condition signal. Hey, can you get him this fish? Right, so where was that other place that we were sending packets from? Client core. Which we didn't need to care about. Send packet away response, send packet away response. Yeah, so we don't have to worry about that. Send packet away response. Based on the timeout, that adds a response waiter to the packet. Wire in the U. Oh, okay. This is also a problem. Oh no, it's not. We just need to make sure that this send packet right, okay, I see. Add response waiter. Right. So our response waiter that we're waiting on here actually needs to be added elsewhere. So if the self dot pivot session. So if we have a pivot session, we want to basically go return add response waiter request completion routine completion. Otherwise, we'll go and do the normal thing. So this is us just bubbling it down, but we're adding the response waiter for this particular request back up to the completion routine that's in the different session. And that's fine. Yeah, okay. So then remove response waiter. We'll need to do the same. So, in fact, we'll have to do the same with notify as well. Oops, I need to do that self.pivot session here. Remove response waiter. Now, rather than call like this line of code directly, so for example, .pivot session .waiters.delete, it's important to not do stuff like this because it kind of relies on an implementation detail that you don't want to duplicate code all over the place, so you're better off not doing that in case there's extra functionality that gets added later on. So whatever lines go in here would also have to go in here referencing the pivot session instead. Return self.pivot session notify response waiter. Now, chances are that things like notify response waiter won't get called by a pivoted session anyway. So this dispatch inbound packet dispatches and processes an inbound packet. So that gets called from here, which never gets invoked, and in here, which again never gets invoked because this is all part of the dispatcher mechanism that isn't even invoked. So I think we're okay. The only concern I've got now is making sure that we encrypt and decrypt with the appropriate keys and GUIDs, right? So TLV anchor key. So when we receive a packet off the wire, we need to make sure that the associated session we are going to have to do like a header parsing thing. So let's go back here. Def parse header, and because we need to route based on, oh, do we? Is that what we actually need to do? So this receive packet, we're not actually going to be routing the packet in a different manner, right? So we just happen to know at this point if the GUIDs are different, but let's just think about this receive again. That's part of the monitor, so it's not going to be at all called on the pivoted session. Yeah, what we're going to have to do is remove this thing here, and we're just going to have to parse the header only. So we'll go parse header, and we'll make an exclamation mark here because we want to indicate that you're modifying the packet at the time. Parse header is just going to do this. Now, do we care about the encrypt flags, length, and type? It is a bit of a copy and paste. All I really care about at this point is the session GUID, rather not even the encrypt flags. So maybe we'll just do that. We'll skip over the XOR key. In fact, we can do this slightly easier, right? So if we skip straight over the top of that, then we can just do this. I can never remember whether Ruby requires the length or the end. Can you? 2, 4, 5, 6. So x of 1, 3 is a length of 3 rather than up to 3. Yeah. Ah, so it is up to a certain index. So for us to unpack the GUID, we would need to go up to 16 bytes. Because we really only care, maybe we should just say parse session GUID and just do that. Because that's really all it's doing. And then we can check the session GUID at this point. Again, this doesn't really matter too much because we're just going to route the packet back out anyway. The question is that on packet receive, there's another one here, right? So this would be parse session GUID and then dispatch inbound packet. Okay, so then at this point what we need to do is we need to go if dispatches and processing. If the packet is a response associated where the weight is notified, all those packets passed to any registered dispatch. Okay, so that's where it's bubbled into the appropriate handlers. We only want to do this stuff here. So if packet.sessionGUID equals self.sessionGUID, if that's intended for us, then we want to say we haven't handled it. So let's leave the handled here. So packet.from self.tlvinc. Then we can go ahead and parse it as we would expect. Otherwise, this is a problem. Okay, because we do need more than that. Packet.response. Okay, let's change this up again. So instead of parse session, we'll change it back to parse header. Because we're going to need all of these things. So that means we can we can reuse this self.parse header, and we can get rid of XOR by itself.raw packet header size through to -1. We know that the header size is aligned, so then we can prevent ourselves from having to do any more work. And then from here, we can get rid of that stuff. Right, so that means that this session good. We need to have a type and a length. And then self.type. No, I don't need that because that's already there. Okay. So, if we pass the header and then later on get all the rest of the data out, that shouldn't affect this because we've got the type already set. Okay. Because type should be part of, there you go, the TLE. Just make sure that there's no, yeah, okay, that's fine. We actually don't need to worry about the length either, do we? So let's get rid of the length. Parse header. Oh yeah, we do need the length. Okay, so with that in place, we should be able to go back to the dispatcher. That's fine. Now this should be fine, right? Because packet.response works off the type rather than doing what method does and working off the TLDs itself. Okay, so then if we skip this stuff, no, in fact we don't need to skip that stuff now that we've done that. We only need to okay, we got a problem. Shit. In order to notify the response waiter, it needs to get the packet response out. Which means at this point up here, we need to be able to get the session and dispatch the inbound packet based on that. Because we won't know whether it, we can't get the request ID out of it ourselves. I think the only way that we can guarantee that this is going to behave is to loop through the pivoted sessions based on GUID. Okay, so that needs to stay like that. So I think at this point, this is where we need to go through and say, hey, if we have a, because we're at the bottom level here and we've just received a packet out. If we've received the packet and we have a bunch of pivots associated with it, self dot, what's the pivot container stuff we've got in here? Find pivot. Find pivot based on packet session GUID. If pivot, so if we, what we should do is just go pivot dot dispatch inbound packet if we have a pivot. Otherwise, we'll go ahead and do our own thing. The only question then is, if we've got this dispatch inbound packet function that gets invoked from here and here, that will end up being called on the parent. It will get decoded okay, and then it will call notify response waiter, which will bubble down. Otherwise, we still want this code, or do we? Maybe we don't. I was going to say maybe we want that code. Messy at Wolf, yes. Messy is indeed a word for this. It's just like with thread, we've got this bulk of code and we're sort of threading a path through this code purely because we can't, we are storing the encryption keys for the packets with the sessions. So you've got to look at the header and then route to the right session before you can decrypt it. You've got to decrypt it before you can look at the request ID and then route based on the request ID. But I still think that is okay. I still think that's okay. Care about that. question here is, what happens after you initialize Meterpreter? So we're in client, the other one is in initialize. Okay. Create the console instance. I wonder if that just magically wires everything else in for us. Oops. Let's just see if this even starts up. I'm guessing it's not going to. Okay, that's surprising. I'm expecting this to be horribly broken. There you go, see, session died. Alright, this is where the fun starts. Why did that die? So, is the thing still running? Let's close this off first, because we don't need this. So it fires up, then it dies. Why does it die? So did we get any messages? Yep. What does it do? Resetting. Okay, so straight away. Attempting to locate base core shutdown. Completion errors finished for. Okay, so it looks like something behind the scenes is saying. So first thing, you can see that it's staging perfectly. We're sending a packet back, and then the next thing it's telling us to do is shut down. So clearly the routing that we've put in place or butchered along the way is causing problems. So let's go back to the packet dispatcher. Good thing is the outbound stuff appears to work, at least for TCP, because this stuff is effectively ignored. That goes out, but coming back in appears to be a problem. Okay, so let's put some debug stuff in. I wonder if we even get there. How long have we been going for now? Two hours 50, that's not too bad. Okay, so we got to here, but the waiter dot wait. Something went wrong. So that would be false. We would end up with the normal waiters. completion routines, etc. Let's just make sure that that's actually a valid reference. Yeah. So it's definitely sitting there. Packet response waiter, wait. Notify, wait. So with that being said, there must be something else that's going on outside of that. We know that packet sending is okay. Now we're not on a passive request, so let's... Pass header exclamation. Monitor socket. Receive packet. That's the problem. Well, I think it's the problem. Let's see. Nope. Session 1 open. What do I want to do here? Unpack. Yeah, assuming they're bytes, that's what I want them to be. Unpack. 0. I love printf debugging. Unfortunately, debugging, like getting debug logs working nicely here for some reason I haven't figured out yet. So I tend to just put a bunch of standard error prints because I know they'll appear somewhere. This log that we've got coming at the bottom there doesn't really show anything useful in this context, and I really should ask how to do that. See, session 1 has died. Okay, so parsing the header seems to be failing. That's good. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. So certainly need to do that. Something that I missed. Why is that line fail? I bet you that's the problem. Extracting header values. Oh man, I can't type. Are there any unit tests? I haven't seen you update any this entire time. Let's see if you can answer that, RESTful Dev. I'm sure that there are actually unit tests and specifications and things like that, and there are things that I will need to update as a result of doing this work. But given the churn at this particular point in time, modifying those tests just to match the stuff that I've done, I think, is a fruitless exercise. Validating whether I've broken something is obviously a different story. There you go, extracting header values. So why is this not working? We are pulling out one 4-byte value, a 16-byte value, and 3 Is that all it is? So yeah, I mean, as far as unit tests go, that's something that I'll look to update once I've done this stuff, because we're mucking with so much low-level stuff. Patching those as we go while I'm still changing stuff doesn't make a lot of sense. There we go. We actually got the header values out this time. Here, parse the header, packet.inspect. What's the bet that my new choked encryption code is, inspection code is the problem here. So we got to this line. Whoops. What am I doing? There we go. We got to this line called parse header. And we printed extracted header values, and then this line died, which means what I did here yeah, that's not gonna work, is it? Because not everything has a GUID. I just wanted to be able to see it. Let's just leave it like that then. Hey, here we go. Still works. Awesome. I'm going to leave these things in here, these debug prints, so that we can see them in action. Let's move that down a little bit. You're laughing at me being surprised, are you? This wonderful book is doubling up as a means for me to prop this microphone up just a little bit higher as well, so that you can still hear me without me ducking down too far. Alright, so now that I know I haven't busted anything, well, now that I know from my rudimentary assessment that I don't appear to have busted too much stuff too seriously, what we now need to do is test to see if our packet pivot stuff works. So if we go into our pivot code, what we want to do is call pivot.create listener. Now, does that even exist? Wrong number of arguments. Okay, good. So, pivot.create listener. We want to give it our current client instance. And we've got to give it some ops. So we're back to pipe name. Pipe name is pipe test. Pipe, I hate it when it does that. Pipe post is 10.1.10.56. Arch is arch x86. God, this is messy, isn't it? What happened there? Undefined method client equals. Pivot, create as a client. Line 28. Really? Do I need to put these attribute accesses near the top? I don't think you do. Copy and paste this so I don't have to type it out again. Undefined method. Ah, yeah. That doesn't make a lot of sense, does it? Doesn't make any sense at all. Get rid of that. Because we don't have the notion of self on a static method. This is a static method. There is no self.client. So this creates the pivot. This is the thing that actually references the pivot instance. So this is the create listener. Sorry for the speed of the dev, by the way. It always slows me down, partly because I'm talking, partly because I'm stupid, and partly because a lot of this code is new to me. I'm quite comfortable on the Meterpreter side. That's an area that I'm feeling pretty comfortable with these days, given the amount of time that I've spent in it. But the MSF side in particular is still kind of blurry. There we go. Let's go and have a look at our process. Threads, no. What am I looking for? Handles. Handles, there it is. Pipe test. Alright. Moment of truth, let's see if this thing actually does anything useful. Okay. Received. Did we get a received pivot packet? Create listener. Packet type response. Core pivot add. We should still have seen this received pivot packet. Core pivot session. Oh, hang on. I know why that's not worked. So let's just go back over here and close this off. Back to Meterp. Now, last time I built this, what did I do? I think I changed a couple of things, but I didn't build it. More importantly, when I built it, I certainly didn't deploy it with the new change. Noob. Alright. So once that's done, let's just kill this thing off in the lazy way. And back over here, we need to go make install Windows. Okay, let's try that again. So that means that beforehand, this was, remember how at the start of the stream I said this said core pivot new? And you can see from what we had up here, where was it? Request, TLVs, type response, request, core pivot add. Alright, so that was the response. And then what happened? Ah, yeah, so we got this request that came out. It looks like there's going to be two issues here, right? First is that we haven't yet decrypted the packet. I do want to see this though. I assume that this method isn't going to come out because it hasn't yet been decrypted. Let's see what happens. Just quickly change this up for a second. What is my job? That's a very broad question. I do wear a number of hats. The short answer is I run a tax simulation company. The long answer is that while I do that, I do a bunch of other stuff as well. And so the stuff that I'm working on right now fits into the other stuff category. Oops. Okay. Right, here we go. Tax simulation. No, I didn't say tax simulation. I said attack simulation. Threat sim, zero scope, red team, that kind of stuff. All right. Receive pivot packet. All right, look at that. There we go. So that came in here. At which point we should have created this new pivot. Now, that means we should have come in here. Probably need to put some debugging here, right? About to create the pivoted session instance. Created. Let's inspect that as well. Self.pivoted session.inspect. Oops, I didn't do that. It's a fun rinse repeat cycle, isn't it? Like Age of Empires, but with netcat and fuzzy bytes. Yeah, let's go with that. And that does include physical world stuff too. Oops. Is it still in here? Nope. Always away, isn't it? There we go. Created. I should create a new stager that doesn't have this debug byte in it, so I don't have to do it this way every time. Okay, pivoted session instance created. Okay. Interesting. So okay, so this is probably where we need to go back to the client. We go session.new. Self.session. Where was that code? Here it is. Aha. Pass along the framework context. Payload UID. Aha, register session. What does this do? Okay, so this is clearly a bunch of stuff that we need to do. We need to register the session. We don't need to care about the onSession method. Do we want to worry about processing auto runs? Notify waiters that they should be ready to rock. I think what I'm going to do is just do this. Problem though is once that's done, let's just go back to the HTTP thing. It's interesting that it creates a session, but the question is, where does the actual wiring of the session creation happen? Create the session, set the framework on the session. So clearly that's something we've got to do. What's this? Set from exploit. let's go back to pivot.rb. So what we need to do here then is go self.client.framework equals, no, self.pivoted session dot framework equals self.client.framework. So that's done that bit there. I'm not going to worry about payload UID just yet. Then I am going to do this. Self.client.framework.sessions.register the new session. Self.pivoted session. If you ever need someone to drop USBs in a parking lot south of the Yarra, I'm your man. Thank you. I will hold you to that. Okay, let's just put some more debug stuff in here. Setting the framework instance. Registering the session with the framework. So the one thing that I'm still slightly confused about is that clearly we were able to create a session, a registered session, a Meterpreter session, but after creating that instance, it didn't do any of the automatic wiring. So when I say that, what I mean is things like loading standard API or checking the session GUID stuff was configured, or doing the TLV related bits. So for example, negotiate, what do I call it? TLV encryption. So client core is what gets invoked. Okay, so client core, negotiate TLV encryption. Oh, that's part of the migration thing. So Meterpreter options is what I'm looking for. On session. Okay. So that means that once I've done that, maybe I need to go self.client. Meterpreter options is part of the Meterpreter session. And it's the new one. So what we want is self.pivoted session. Once the session's created, automatically load the standard. Okay, so yeah, this, what I don't understand is why it's calling on session when itself is effectively the session. Invoking the on-session method. If there's anything here that I'm not explaining so well, then let me know. Oh, I didn't see Peleus come in. To answer your question, Alicia, I assume that's your name, Alicia. A little bit more detail. I've done quite a bit of dev in the past, which is clearly what I'm doing now. Oops. Is it going to remember? Nope. It's still on the clipboard. Yep. Okay. Oh, invoking on. Oh, look at this. Meterpreter session 2 opened. We don't have any detail at all. Which isn't surprising. Yeah. It's only got the core commands. Okay, so our dispatching isn't currently working. So what I want to do next, looks like the basics of the session creation are actually happening. Feel like we're getting closer at least. Question here is, let's just make sure we are where we think we are, because I don't think we are where we think we are. Meterpreter options on session. Then it actually schedules another function. So let's go on session didn't actually work the way I wanted it to, so we didn't get in here, and that's good, because otherwise I would have cried a little bit, because it wouldn't have made as much sense. So we're creating an instance of this which doesn't have Meterpreter options in it. Session method in here. Where am I looking? Pivots. Okay, so where does Meterpreter options come into play? Meterpreter loader is the thing that includes it. So does that mean I need to do the same thing with a session as I do with this thing? Maybe I do. So if we go s equals class.new and give it Meterpreter, and then we go s.include MSF sessions Meterpreter options. And then pivoted session equals s dot new. I don't even know whether or not that's how it works, but let's have a look at what the Meterpreter loader looks like. So am I in the right spot now? Java, Python. Yeah, right, there we go. That's where it is. Modules, payload, stages, windows. Stage, windows. Meterpreter. There it is there. That's okay. I think that's probably going to be enough. Is it? Is it going to be enough? Only one way to find out at this point, eh? Still going. Fat fingering badly. About to create a pivoted session instance. Okay, so it's not happy about some. Oh, hang on. Probably going to need that in here. Nope, still no issues. Let's run this again. Yep. There's no error. rolling rinse repeat cycle, this isn't it? Okay, so adding that Meterpreter load has clearly caused issues. And I don't know why. So that was fine. Let's figure out exactly which line this is dying on. I would assume that it's dying on this one here. So just to be sure, if we go begin. Is it accept? No. Rescue. Standard error puts speed up. Inspect. Maybe I should just wrap the whole lot in that and see what's causing it. Funny how I can have Guyver on in the background the whole time and I don't get sick of it. Pivoted session, setting the framework instance. Pivoted session instance created nil. Okay, that's completely different to what I was expecting. Ah, yeah, right. So yeah, it is this line here because I didn't bail out. Wrong number of arguments given to expected 0/1. Really? Okay, so that's a problem. That is a problem. So we're giving it nil and ops to create this instance, but we want to be able to pass that through, whereas this is saying it's only expecting 0 or 1 arguments. So how do we create an instance of a session in this manner? Effectively what we want to do is wire this all into the session itself, and that doesn't appear to be possible. Is that because it's a module? I don't think so, because when we do this inside here for, sorry, not here, when we create the instance of the payload, okay. Maybe what we can do instead is reuse this. All right. It's now 5:30. I'm getting pretty close to finishing up for at least streaming for the day, but maybe we can quickly bash out something new while we're sitting here. This pivot container has individual pivots. It also has pivot listeners. So what I want to be able to do here is keep track of the listeners and the classes, the stage of classes that were associated with them, right? The pivot listener will have exactly the same sort of stuff. So I've got this pivot class here. I'm just going to add it to the same file, even though I will break it out later. TTR accessor. It's going to have a pivot ID and a stage. Alright. For now, that's really all I care about. ID instead. So once we've created that, right, what we're going to do is go type pivot ID, and we're going to generate an ID. Packing or unpacking. I do this all the time. Require secure random.uid. Gsub, get rid of the dashes. Pack. There it is. Okay. So got a pivot ID. I'm going to send that through. And then we're going to go client.add pivot listener. Initialize. actually, what we should do. So we'll just create one on the fly. Saves, don't worry about that. We're going to have to go. Pivot listener.new. Okay, so when this gets created, we end up down here, and instead of this, we should be able to go s equals so we got our listener, which we should be able to get out of client dot find pivot listener. Oops. Need to be able to get the listener ID out as well. So that's going to come back in up here. What did we call it? Pivot ID. Listener ID, so then we can go listener ID. That should give us a reference to the actual listener. And then from here we should be able to create a session based on the stage. Because I think that's exactly what happens in the handler. Because the session is wired into somewhere. So we want to be able to do this. Payload was merged in this associated session factory, allocate a new session, which is exactly what we should be doing. That was me adding support for multi with the create session stuff. And that checks for things based on UUID, which we don't currently have. So instead of doing this, listener stage. Kind of hoping that we can do something like that. Before we do this, let's just do a standard error. Let's inspect a couple of things. Oops. See how much I broke. Oh, that's not going to work. Stop. We've got to go to packet. Actually, let's do this. pivot ID as part of our TLV, and we also need to do that on the Meterpreter side. Okay, so from there, when we actually handle the pivoting, where is that? So pivot name pipe. There's a request handler in here. Named pipe name comes out of the thing. To do is add some extra thing here with a context. So that's the name. What we're going to do is we're going to have another GUID here, which is pivot ID. Okay, so then what we can do is when the request comes in, request call pivot add. Go LP byte pivot ID equals packet get TLV value raw packet TLV type pivot ID. Now we want to make sure that if that is specified, because God only knows that this may actually happen, though it never should. We want a mem copy from into the address of context pivot ID, and size of context pivot ID. So that gives us a pivot identifier. And that means that when we send our packet back, when we create a new one, where is that code? Serve and notify. It's in here. Here we go, new session. Here we go. Create add TLV raw. Notification, TLV type pivot ID. LP void address of server context dot GUID. Pivot ID, sorry. Size obs in here. Okay, so now when we get a new session come in, we're actually sending the identifier of the pivot that we were given that was associated with the listener. And then on the flip side, with that in place, we should be able to look up the stager that was associated with that when we first set up the name pipe pivot, and look up the stage instance and generate a session based on that stage instance. What does that give me? LP byte? Yeah. It's me dereferencing one too many times. We've still got 21 people listening. Clearly you're a bunch of suckers. Still building, or have I failed again? I failed again. Oh, I tried rebuilding while it was still building by the looks. There we go. Oops. Windows, okay, payloads are ready. $15. Come on, we've got to have something. Gotta have something. That's at least still working. I don't have the magic on the clipboard anymore. Ooh, what happened here? Pivot container, add pivot listener. That makes no sense. Undefined method, no vanilla. That doesn't make any sense. So, oh, hang on. Oh yeah, no, that's okay. Where were my wingmen? That's you guys. The Fridge Master. Alright, here we go. Got a good feeling about this run. Gonna see some magic happen. Oops. Ah, man, I hate Ruby Readline. Woo! Look at that. I don't even know what happened there. I've done an inspect at the stage, I betcha. Is that what I did? Response found. Pivot listener. Whoa. Okay, yeah. Yeah, okay. That's a problem though. Let's see, that stage is actually the raw bytes. We don't want the raw bytes. We actually want the class that we generated the stage from. So we don't want the stage, we want the stager. So that should instead be pivot listener stager. Because we want to be able to pull the data off the stager, not from the stage. That's pretty stupid. So then down here when we initialize pivot session listener stager. So let's make sure that's legit. Fridge Master, thanks man, or lady, whoever you may be. I appreciate that sentiment. I often feel like all I do is flap and ramble on stream, but people seem to get a kick out of it regardless, which is nice. And that's the point, right? Hopefully people learn something, and if they get sick of it, they can just switch it off. Yeah, that's better. That's much better. That's exactly what I want to see. Okay, so somewhere in here, I would hope, it's pretty ugly to look at, isn't it? Somewhere there should be a reference to a session class that will allow us to create an instance of a session based on whatever it is that we've just had come in. And well, we'll soon find out, because we're going to kick this puppy off. This will be our final run for the day, I think. Unless we get agonizingly close, at which point I'll want to do more. Setting the framework is okay, so new for nil.nil class. Okay, so clearly I don't have the means to get to the session from this location, but there will be something in here that will allow me to do so. Let's see what this says in a useful editor. Let's do no. There is no session info in here whatsoever, is there? So if we go back to this Meterpreter options thing, see we've got auto load, standard API, session, retry, wait. None of those things appear in here. So perhaps what we need to do when creating this is include that at that point. Payload stage, transport config. Is it sessions? Sessions. Hang on, it should already be in. Oh no, it shouldn't. No, it shouldn't. Maybe I need to do that there. Now we should at least see this break when I do one thing. Yeah, Fridge Master, I agree, mate. It's one of those things, like, it doesn't matter how much people succeed or fail when they're doing it, but just watching them go through the process of solving a problem or exploring areas of code that you're not familiar with, you know, there are so many things that you can get out of watching someone fail at something. And then when they succeed, you know, every now and then it slots things into place even more so. So I agree. I enjoy watching people code. I enjoy watching people game as well, for that exact reason. Did you include at Wolf? No, I didn't, but I know that they are already included. Actually, I think they are, because we had them before. So it wasn't failing on references, which is what I thought it was doing to begin with. have sessions? Yeah, I do. Oops, that's bad. Where are you? Yeah, that's not what I was hoping for. Where's my piece of code? It's up here, isn't it? There it is. Ah, it didn't work that time. Why is that? Unreferenced local variable ePivot. Yeah, that's not the same thing. Wrong argument type class in 59. So, okay, let's get rid of this for a second. Okay, so I can't include that mix in. Maybe there's some magic to include a mix in inside a class definition. Hang on, because transport config, that's just a module, which includes just fine. So here we should be able to include modules as well, like Meterpreter. So if we, wrong one. Ah, it's a class. Meterpreter options is a module. What I need is to get a reference to, so we end up with a stager, don't we? We end up with a stager, a payload that includes a stager. I wonder if it's worth there is a way that we can actually include the reverse TCP, reverse name pipes handler in here, which references the appropriate session. Man, this is hard. So here's basically where I'm going. What I'm trying to do is make it so that we create not just an instance of a payload, which we can generate a stage from, but somehow we can use this information to access a session instance that matches the stage that we've sent. And that's why this payload stager, let's go lib, what's that called? Payload stager. So there, that's already including the transport config, so I don't need to do that myself. We can get rid of this, and it should just work. Now this clearly doesn't work. Interpret options doesn't make sense in the context of a stager either, does it? So that does all of this stuff. Maybe it does. Maybe it does make sense. So this does a bunch of crap for us. Initialize. But this has nothing to do with. Return the session class that's associated with this payload and will be used to create a session as necessary. Module info session There was nothing that got spat out before that referenced module info in here, right? At least I'm sure. Ah. Oh, isn't that interesting? Module info copy. Aren't platform ref licensed references. So it's got everything in there except, oh, hang on. Let's go back further up to where there was more. So there's a module info copy, but here's a module info. Starts there. References, payload compatibility, stage, encoder. Okay, so there, I think it stops. That's why we're not seeing anything in dot session. This is interesting. There's a UUID in there. Platform. I think we're getting to a point where it's fair to say that what we need is the ability to take something like a stage and say to Metasploit, here's some information about a stage, go and create me an instance of a session that matches the stage. And that might be what we need to effectively build here to begin with, and then we can abstract it out so that it's used in different places. But I can't see anything specific to the session at this point, which means we need to merge in the thing that has the session information in it, which I believe is in lib. Core handler. Handler name. This is not it. Payload looks at as Meterpreter loader and Meterpreter as payload. Yeah, that's the kicker here. What would be fantastic is if we could somehow refactor this so that the session lives outside of this. To me, it would probably make a bit more sense to move this into the Meterpreter loader rather than leaving it in the Metasploit Meterpreter module. I'd have to talk to some powers that be before I did something like that, because so the kicker here too is that this not only has it's got the loader in it, it's got the session, and it's got the options for the session, and it has the exact session instance in it. But we don't necessarily want to push this down, and I don't know whether we can create an instance of this on the fly. See, we create an instance of a payload because we need, the payload is based off this. No, this is just the stage, not the stager. Sorry, this is just, yeah, this is just the stage. So if we look at payload stages, Windows Meterpreter, sorry, Windows reverse TCP. This has nothing to do with Meterpreter because it's used for shells and various other things. So that's kind of irrelevant. What we want is I effectively want to create an instance of this. If I could easily create an instance of this module, rather than doing it as part of the pivot. So see here, I'm referencing payload and the stager and the loader directly. See, because these are modules, not classes, spinning up an instance of this on the fly. I don't even know if that's possible. Probably is. Let's see what the internet says. Excuse me. There's a number of ways, apparently. I guess not. I don't want to do any of that. God, man, some of this stuff is horrible. I effectively want to replicate these two things. How do I create an instance of stages Windows Meterpreter? I wonder if I'm doing this all wrong. I know that the framework instance, which is referenced off the client, has collections of payloads and stages and all that sort of stuff. So maybe what I should be doing instead of trying to do it this way is ask the framework to give me a copy or create a new stager based off stuff and use the stager that it gives me to go ahead and create the session instance. That would make a lot more sense, right? Yeah. Anyway, it is 6:10. We've been going for 4 hours and 20 minutes, so I'm going to call a halt, go and do family stuff, and I'll come back to this a bit later on. I probably won't stream later today though. Instead, probably fire things back up tomorrow. So thanks to all for listening, bearing with me. Hope it wasn't too painful. And yeah, fingers crossed that we can make just a little bit more progress tomorrow to actually create valid sessions. And from there, we should actually start to see packets going along the directions that we should be seeing them. So fingers crossed. Thanks, guys. Take it easy. See ya.